In this video lecture, I'm going to discuss resolution in FOL. FOL stands for first order logic. I have already explained first order logic. If you have any doubt, then you can check FOL video, right? So, first of all, we should understand what is resolution. Let's suppose we have n number of statements or various statements, and we need uh, to prove a conclusion. So for that, resolution is used. That means with the help of resolution you can prove a particular conclusion, right? And resolution is what? It's a single inference rule which can efficiently operate on the conjunctive normal form or causal form, right? So resolution is a single inference rule which can efficiently operate on conjunctive normal form, which is also known as CNF, right? Now, what is clause? Clause, disjunction of literals. Literals is what? Atomic statements. I have already explained types of statements, atomic and compound, right? So, disjunction of atomic sentences is what is called as clause, and it is also known as a unit clause, right? Now, conjunction normal form, it is a sentence represented as a conjunction of clause, right? What is conjunctive normal form? A sentence represented as a conjunction of a clause, right? So now I'm going to discuss the steps for resolution. What are the steps involved when you are using resolution? Total we have 4 steps. Number 1, conversion of facts into first order logic. That means few statements are given, right? So you have to convert those statements into first order logic. I have already explained universal quantifier and existential quantifier. So with the help of these quantifiers you can convert your uh, statements into first order logic. Second step is to convert your FOL statements into CNF. FOL statements into CNF. And third step is what? Negate the statement which needs to prove. Third statement, let's suppose you have to prove that, you want to prove that few boys are stupid, right? So, few boys are stupid. So, for this conclusion, what you have to do, you have to negate that conclusion. That means few boys are not stupid, right? So, you have to prove that conclusion. So, third step is to negate the statement which you want to prove. That means proof of contradiction, right? Now we are using proof of contradiction. Fourth is draw resolution graph. That means unification. I'll explain unification, right? No need to worry. So, fourth step is to draw resolution graph. So, with the help of example, we can easily understand the concept of resolution. So, now I'm going to take an example. So, in this example, 5 statements are given, right? In this example, 5 statements are given. First statement is John likes all kind of food. John likes all kind of food. Second, apple and vegetable are food. Third, anything anyone eats, anything anyone eats and not killed is food, right? Fourth statement, Anil eats peanut and still alive. Anil eats peanuts and still alive. Fifth statement, Harry eats everything that Anil eats. Harry eats everything that Anil eats. So these 5 statements are given, right? And now one statement is given that you have to prove with the help of resolution, and that statement is John likes peanuts. John likes what? Peanuts. Okay, now question is clear, example is clear. Now what is the step number 1 in resolution? Hmm? The first step in resolution is conversion of fact into FOL, that means first order logic. These are the facts. These five statements are the facts, and you have to convert these fact into FOL, which is your step number 1. So try to understand. John likes all kind of food. All means for all, right? It's a universal quantifier. So in this case, for all x, point A, point A for all x, food x, right? Food is what? Food x. Your statement is John likes all kind of food. In this statement, food is what? Food is predicate. So for all x implies likes John comma k. It's a first step. Second step, apple and vegetables are food. So and quantifier will be used, apple and point B, apple food, apple is also a food and vegetable is also a food. So food apple and food vegetable, right? Now third, anything anyone eats are not killed. Anything anyone eats, for all x, for all y, eats x comma y, eats x comma y, then anything anyone eats. So anything anyone eats will be converted for all x, for all y. Eats is a predicate here, so eats x comma y, and now we are using and, not killed. Not means negation. Not, try to focus on the step number 3, that means C point. Negation, killed x is food, is food. So it will implies food. Okay, I hope this is statement number 3 is clear. If you have any doubt, pause this video and again try to understand. Okay, now fourth step. Fourth point is Anil eats peanut and is still alive. Anil eats peanuts. So first try to convert this statement. Break your statement into subparts so that you can easily convert your statement into FOL. Let's suppose in first, second, third statement, you'll feel very difficult to convert this statement number 3 into FOL. So no need to worry. First break this statement into two parts. Anything anyone eats. Anything, that means for all x, for all y, right? So first convert this first part and use and quantifier. After that, not killed. Then use not killed. That means negation, is food. Is food, that means is, that means implies food. Hmm? The statement number 4 is Anil eats peanuts and is still alive. Again, Anil eats peanuts. I will break this statement into two part. Anil eats peanut, that means point number D. Eats Anil peanuts. Eats Anil peanuts and alive. Whole alive? Anil, right? So step D. Now step E is Harry eats everything that Anil eats. Harry eats everything. E. For all x, eats Anil, comma x. For all x, eats Anil, comma x implies Harry eats everything. Your statement is Harry eats everything that Anil eats. So first we have to write Anil, right? So in step number E, in point E, Anil, right? Anil eats what? Anil eats everything that will be eaten by Harry. So five statements A, B, C, D, E. Now total five statements are converted in FOL. Now in FG, try to understand. In FG, for all x negation, killed x implies alive. Now we are adding these predicates. Try to understand. In this statements we are adding these predicates. Negation, killed x, that will alive x, that will implies alive x, and alive x implies negation killed x. That means if you are writing killed x implies alive x, or if you are writing alive x implies negation killed x, both the things are same. so you can use this. Okay, last statement, John likes peanuts. So you have to prove this, John likes peanuts. So John likes peanut, what will be the conversion? Likes John comma peanuts. I hope step number 1 is clear. Now going to step number 2. What is step number 2? Step number 2 is to convert your FOL into your CNF, conjunctive normal form. Right. So first, what is the in first order logic resolution? It is required to convert FOL into CNF. Right. It makes easier, right, for resolution proof. So first step is to eliminate implies. Right. So this is the result of step number 1. After step number 1, you will find the solution from A to E. Now what you have to do, now you have to convert this FOL into CNF. So for this, first you have to remove implies. So in A, C and E we have implies symbol to try to remove. So one formula is given, A implies B. Let's suppose A implies B, you are using A implies B. So you can write this statement in the form of negation A and B. Why we are using this formula? Because in this case we have to remove implies symbol, right? So for implies symbol, if you want to remove implies symbol, so you have to put what? This formula. So you can easily put this formula. That's it. Not to worry. After that, next step is to move negation. Move negation and rewrite. Now try to remove negation, and then rewrite your sentence, right? And you can also, next step is to rename variables or standardized variables. So let's suppose you have, we are using x everywhere, x and y everywhere, right? So you can rename variables, like in first x we are using x, in second we are using apple vegetable, in third we are using yz, fourth we are using anil and peanuts, then we are using w, g, k, right? So we are using standardized variables. After that, existential quantifiers, you can eliminate existential quantifiers. What are existential quantifiers? Like for all, is there exist, not for all. For all is your universal quantifier, right? Is there exist. So if you find that is there exist, this keyword is used, this quantifier is used in your statement after conversion from FOL to CNF. So first you have to remove this is there keyword, is there quantifier also. But in our solution, is there quantifier is not used, so no need to worry and no need to remove. Okay. After that, drop universal quantifier. See, this is the solution. This is the final solution of step 2. Not final, but it is near about, you can say it's a near about solution, right? So in one modification is required. What is the modification? Modification is like you have to remove universal quantifier. So after removal of universal quantifier, this will be the final result of step 2, right? I know step 2 is very lengthy, no need to worry, right? You can easily understand. See, one note is given, food apple food vegetable. If you are using food apple and food vegetable and eat anil peanuts, and you can return these statement into two different statements. Like in this case, one, two, second statement, food apple and food vegetable. It's a single statement. You can break the single statement into two statements, like food apple, it's a single atomic statement, and food vegetable, like in this solution, step 2, step 3, right? Now, step 3 is what? Step 3 is to negate the statement to be proved. What was the statement? Likes John, comma peanut. Likes John, comma peanut. Let me show you. H. H statement. You have to prove this statement number H. John, comma peanuts. So what will be the negation of this statement H? Negation likes John, comma peanut. It's very simple. It's your step 3. Now C, negation like John comma peanut. Step 4 is to draw resolution graph. Step 4 is what? To draw resolution graph. C, negation likes John comma peanuts. So when you are drawing a graph, resolution graph, first you have to understand that what is your final conclusion. That means which what conclusion you want to prove, right? And let's suppose your conclusion is in negation form. Yes or no? Yes, it is in negation form. So now you'll find the same sentence, same you can say statement, right? So that this negation, and that statement without negation cancel out. Let's suppose likes John comma peanuts. You have to prove this statement. So now you have a set of statements. After second step you have these statements, right? So now you have to check negation. What was it? John comma peanuts, right? Now you have to check John comma peanuts where John comma likes John comma peanuts or similar statement is present or not without negation, right? So this statement is given. So in this case, John, this likes John, negation John, and this John both will be cancelled out. So remaining part will be food peanuts. What will be the negation part? Food peanuts, because likes John both will be cancelled out. Now negation food peanuts, right? Negation food peanuts. So again you will check food peanuts, right? That variable can be modified. It is not required that food peanut will be there. No, negation food, that means now you have to search food. So in this statement, and you will search where you will search a set of statements, right? In a set of statements. So food peanuts, here food x, food z, not x. So both will be cancelled out. So remaining part will be negation eats y comma z or killed y. Now you will check this statement. You will find eats Anil comma peanuts. Now eats will be cancelled out. So the remaining part is killed Anil, not negation. Now killed Anil. Now you have to check negation killed, right? Before this killed, we have negated statements like negation likes, negation food, negation eats. So what we were doing, we were searching for not negated statements, right? But now we have a killed Anil, that means now we have a normal statement, that means now we have to search negated killed, right? So in this statement, negated killed is there. So killed will be, both will be cancelled out. Now remaining part is negation alive Anil. And then now we have to search alive without negate element, which is also present. So both will be cancelled out. And this empty bracket will show that our conclusion is hence proved. So hence the negation of the conclusion has been proved as a complete contradiction with the given set of statements. And still you have any doubt in your resolution graph, so some steps are given, explanation is also given, so you can read this explanation. With the help of this explanation you can easily understand the resolution graph. So it's all about resolution graph. Okay, so try to understand, it is very important topic in RCA 403, right? If you have any doubt, then you can comment. And okay.